Good afternoon, PreCal students. Hope everybody has had a fantastic Monday up to this point. I know today's lesson will actually add to your day because you guys are going to do awesome on this lesson. We're doing 5.2 today. The title of it is Rational Equations. It's on page 230 in your ebook, so if you want to open up there and follow along, that's fine. But there's really a couple things, just two objectives today. We need to be able to solve rational equations, and then we need to use the domains to check for extraneous roots of rational equations. So it sounds like kind of difficult work, but it's actually pretty simplistic. A rational equation, as defined on page 230, is simply an equation that contains at least one rational expression. So we're going to be solving equations that have rational expressions in them. In other words, they basically just have a unknown in the denominator. So I'm going to work a couple of examples, show you how this works, and then assign you guys the problems for homework, and you should be good to go. So the first problem is example 1. You guys can see it in the textbook. I'm just going to put it up here on the screen. You can follow along with me. I encourage you to have out some paper. That way you can work the problem with me and make sure you know what's going on here. So we have, you can see why this is considered rational, because we have two unknowns, two variables, same variable, but it's in the numerator and the denominator on both sides of the equation. So we got to figure out a way to simplify this and solve this. There's actually a very simple way to do it. You could just cross multiply. That's going to make your work a little bit more difficult, but you could do that. I'm going to recommend to follow the steps that I show you. That way you'll definitely be successful on this. So step number 1 is multiply both sides by the common denominator. So if you look at the denominators, n minus 5 and n minus 4, I literally just need to multiply both sides by the product of those denominators. Now when I say product, I do imply multiplying, but you do not want to multiply them out. So I'm going to say n minus 5 times n minus 4, multiply that side, and then multiply this side also by n minus 5 times n minus 4. Okay, so we multiply both sides, and then when we do that, you guys probably already know what happens here. The denominator is going to cancel out. So this is just a fast way for me to get rid of my fractions. And then you're left with 3n times n minus 4 equals the quantity 3n plus 1 times the quantity n minus 5. So really what I did is I multiplied by common denominators to get rid of my fractions. That's really the main goal here. So now what I do is I just FOIL this out and simplify it. I distribute out the left side. That's going to give me 3n squared minus 12n. That's going to equal, here you have to use your FOIL method real fast, but when you use your FOIL method and simplify it, you're going to get 3n squared minus 14n minus 5. If I confused anyone, I just went ahead and simplified it after I FOILed it out. Okay, well, this one's convenient. You guys see you have 3n squared on both sides, so if you subtract it, they're going to cancel. And then I'm going to go ahead and add the 14n to both sides. And when I do that and simplify, I get 2n is equal to, negative 5. So n apparently is negative 5 halves. Now the problem with all of these rational equations, you always are going to have to check your work. I know it seems like a non-essential, but it actually is, particularly in the next problem that we're going to work. But you just simply take the value here and plug it back into your original equation that you guys see on the screen in red. And you check it out, make sure it does satisfy, that one side does equal the other side. And sure enough, on this particular problem, after we were to check it, we'd find out that that's what we get. We do get the answer there is negative 5 halves. So I'm going to work another one here. This is example 2 in your textbook. 2x minus 1 divided by x plus 3 plus 1 divided by the quantity x squared plus x minus 6 plus x minus 4 divided by x minus 2 equals 0. So here again I have a rational equation. It's an equation because it says equals. So I want to get rid of my fractions. So the way we do that is we multiply everything by the least common multiple. So look at your middle term here. This term, I'm putting a star above it right there. I need to go ahead and factor that denominator. When you factor that denominator, you're going to be left with x plus 3 times x plus 2. We just factors of -6, when you add them together, give you a 1. That's actually not correct. It should be -2. Let's clean that up a bit. Sorry about that. X plus 3 times x minus 2. So the reason you take the least common multiple is because you want it however many times it mentions it the least. And you look at your first term here, it has an x plus 3. You look at your second term, there's an x plus 3 and an x minus 2. And then you have your last term, which is an x minus 2. The one that has it the most is this middle term right here. So that's going to give me my least common multiple, or least common denominator in this case. So literally I take my least common denominator and I multiply it times every single term. It seems like a lot of work, but you guys are going to notice very quickly what happens. It's going to simplify quite a bit. My first term, I'm left with x minus 2, that quantity, times x, or 2x minus 1. Here, everything cancels out. So I literally just have plus 1 there. Makes it very simple. And then here the x minus 2 and the x minus 2's cancel. So I have plus the quantity x minus 4 times what was left over, the x plus 3, and all of this equals 0. So again, whatever the lowest common denominator is, you multiply each term by that to get rid of your fractions. You guys have been doing this a long time. You just may not remember how to get rid of your fractions, but that's the way we do it. So then we just FOIL everything out, and when we do so, we're going to get 2x squared minus 5x plus 2 plus 1 plus x squared minus x minus 12 equals 0. So you just continue to simplify this, and I'm going to be left with 3x squared minus 6x minus 9 equals 0. Now from this point, we could actually use the quadratic formula if you'd want to, but since it's an equation, I'm going to go ahead and divide out or factor out a 1/3 because all of these numbers here are divisible by 3. You can say factor out 1/3, but technically what I'm doing here is I'm dividing everything by 3. So divide that term by 3, this by 3, and then also that 0 by 3, because what you do to one side you have to do to the other. Then you're left with x squared minus 2x minus 9 equals 0. And this actually factors very nicely. Factors of -9, when you add them together, give you -2. Those are going to be plus 1. This should be a 3. That's why it's not making sense. Plus factors of -3, when you add them together, give you a -2. That's plus 1 and minus 3. So based on the product rule, we know x has to be equal to -1 or 3. Now, this is very important. This is where you definitely have to check your work. The only part you're really concerned about is the denominator, because potentially one of these two numbers here could actually give you a 0 in the denominator. So I really care about that denominator, this denominator, and this denominator. So you really just have to check and make sure they do not give you a value of 0. So you can do that real fast. You can plug in the -1. -1 right here plus 3 would give us -2. That's good. -1 minus 2 would give us -3. That's good. And then I'm going to use the factored piece right here. -1 minus 3 is 2. 2 times -3. I get a number other than 0. That's all that matters. So -1 checks out. Then you check negative or positive 3. You plug it in. Also, this one checks out. So you actually do have two answers for this rational equation, -1 and 3. You potentially could have no answers. When you do all the work, you get an empty set for both of them. That's very possible. And also, often you could possibly just get one answer. So maybe I plugged in, maybe let's say I got -1 and I got a 2. Well, if you plug that in, that checks here, it checks here, but the 2 does not check here. It'd be 2 minus 2. Which would give us 0, which would make it undefined because we can't divide by 0. So you always have to check your answers whenever you're working with these rational equations. Well, guys, that's the whole lesson today. Very short, very quick, but very important. So your homework tonight, you're just going to be practicing a couple of these problems. I want you guys to do numbers 1 through 30, technically 2 through 30 because it's going to be 2 through 30 even. So lesson 5.2, numbers 2 through 30 even. That's what you guys will be working on for homework tonight, and it'll be due tomorrow. Hope you have a fantastic Monday, and look forward to seeing you later this week.